In this video, we will map vulnerability of groundwater to contamination using DRASTIC method. DRASTIC method is an overlay analysis technique for determining the aquifer vulnerability. It uses 7 hydrogeological parameters to calculate DRASTIC index. These parameters includes depth to water, net recharge, aquifer media, soil media, topography, the impact of weather zone, and hydraulic conductivity. So let's see how it's calculated. First, we will get all the raw data, then convert it to drastic parameters. So I have already done it. So you will find in this exercise these data set already prepared, and you just have to process this parameters, which are depth to water, which is D, net recharge, which is R, aquifer media, which is A, soil media, which is S, slope, which is T, or topography, and impact of weather zone, which is I, and hydraulic conductivity is C, which makes up a drastic. So you will process it all and in a GIS and make drastic vulnerability map of groundwater contamination. So this is the equation to calculate drastic index. So here you have rating of your first parameter, depth to water, and then there is a weight assigned to it. So it's a weighted rated method, which is basically a weighted overlay method to calculate the vulnerability using these 7 hydrogeological parameters. So how to assign this rate and how to assign this weight? We have to see the literature. So this is the table which we will use in this exercise to calculate the weights and rates for each parameter. So for depth to water, we have to classify our image into these classes. So then according to each class we will assign the rate, and each parameter will have a weight. So suppose if our depth to water ranges from 0 to 1.5 meter, then we will rate it as 10, and if it is 1.5 to 4 meter, we will rate it as 9, and 4.5 to 9 meter, it is 7. So shallow water tables high ratings and deep water tables low ratings. And then once we have rated our depth to water especially into the area, then we will assign weight 5. So you will see it later on. So we will do similarly for each parameter. We will have rating according to its classes, then weight according to its influence on the contamination, or its role in the contamination. So what is the procedure for doing it? First step is you open ArcMap, then add your data of all the parameters which is already prepared. Then we have to classify our layer according to table 1, which is this classification. So we have to classify according to these ranges. Once we have classified these ranges according to the table here, then you can assign these rates using Raster Calculator. Once you have assigned these rates using Raster Calculator, then you can again use Raster Calculator for using this equation. So here this is the rating raster, and after rating raster you will have these weights. So you can see depth to water table is given 5 weight, net recharge 4, aquifer 3, soil media 2, topography 1, weather zone 5, and hydraulic conductivity 3. So you can see it here 5, 4, 3, 2, 1, 5, 3. So these are the weighted rated equation. So this dr we will prepare based on the classes, and then once you have calculated the drastic index, then you can easily classify it into low vulnerable zone, moderate vulnerable zone, high vulnerable zone, and very high vulnerable zone. So we will first open ArcMap and add the data. So our data is drastic D R A S T I and C. So this is your drastic parameters. Now first step is to classify according to its ranges as given in this table, which is table 1. So first we will take parameter depth to water and classify it according to these ranges. So I will do it here. So you can see I will just close all other parameters. Our depth to water table ranges from 0.78 meter to 7.5 meter. So it is from the top of the surface to the water table. So now let's classify it. So we will use classify, we will classify in 3. Now we will assign threshold, so you can go classify, you can put it here manual and put the ranges, like our upper ranges are 1.5, 4.5, then greater than 4.5. So in our case it goes to 7.5. So upper than. So here in the labeling, because I know how the ranges are, so I will label it according to the tables of 0 to 1.5, and then 1.5 to 4.5, and then greater than 4.5. So it's just labeling your actual data is here. So you can color it if you want, like uh, color it into shallow to deep water tables. Press OK. So you can see it here. You have one zone where you have deep water tables. There is another zone which is shallow water tables, and for moderate water tables. Then you have a shallow water tables. So it is basically assumption of this method is when it's shallow, you're prone to more contamination. When it's deep, you are less prone to contamination. So that's why you will see in weights, shallow will be assigned the maximum rate, and or deep will be assigned less rate. So it's 10, 9, 7. So now what you have to do is basically uh, convert this depth to water classes into rating, which is basically DR. So you have to rate it. So your all this area which is greater than 4.5 will become 7. This moderate area will become 9, and this shallow area will become 10. And drastic rating values. So let's first do for all the parameters, and then we can do rating and weighting once one by one. So our depth D is done, so we can minimize it. Now our recharge value for recharge, and for recharge we have this range 0 to 175, 175 to 250, and greater than 250, and recharge is given in millimeter per year is annual recharge. So let's see, we'll classify it. We'll go to properties, symbology, classified. We'll give it a 3 classes, and we know now the ranges. We'll put a manual value. The ranges will be 175, 250, and greater than 250. So I'll give, see it once again. So 175, 175, 250, and then greater than 250, whichever it is. So I will again label it here. You can just assign it color. Label it here like as in the table, 100 to 175. So our minimum value is 126, then 250, and then greater than 250. We'll press OK. So most of the area we have, because it's an irrigated area, surface irrigation network is really high, and here you have less because of only rainfall is acting. There is less irrigated area into the region. This is desert area. So here all is the irrigated area, and river Indus is also flowing from here. So now let's come to aquifer media. So we have considered like it's a highly transversive sandy aquifer. There are almost the same aquifer is underlying, so it's only one value here. So we can assign directly the weights. So there is no other classes. So we have only one type, which is sand and gravel. It's okay. It's already one value in an aquifer. So as you can see, only one value. Now let's come to soil media. So we have three types of soil media, and so we have to assign sand, loam, and clay. So we have three types of soil media here, and we have to assign each value a number later on. So I know that in my case, let's see, I can open my presentation so I can see which type of soil it is. Yes, my one is sandy soil, two is loomy, and three is clay. So I can just label it so I can identify later on. So I will just label it here. This is sand, this is loomy, this is clay, this is upper soil. Mostly loomy clay because of the agriculture area, upper soil. So I can give it a color so we can recognize it later on. So let's give it a color which is more suitable to its description. Mostly the area is under loomy and clay loam. There is sanding at the desert side, there is some sand, and there are some patches of sand dunes here, which is because of the river migration maybe. So this area is all desert, so we can assign it all the sandy stuff. So now let's come to the topography or slope. So it's really a flat terrain. There is some high values. I think this is error, but this lies really out of the range because mostly I know this is a flat terrain area. Some sand dunes may be to the west side. So let's classify it. How we have to classify? We have to see here. So as I know, it's very flat, so 0 to 2% of slope. It's only one value, I think. So we can just see. Can make it two classes. Yes, this is some outlier. This is some outlier which can remove it. Or yeah, this value is some outlier which we will neglect to remove it later on. We'll assign it zero value in the reclasses scheme and assign here some rating value. So let's move forward for so this impact of wedo zone is also like mostly the lithology of upper soil is like the wedo zone is also like the sandy is a continuous aquifer. There is no changing layers much, so sand clay layers you will find thick sand and very less clay layers. So we'll assign one value, so it's already one system, so when we will define the rating we can use it, so that's okay. Now the conductivity ranges. So for the variable conductivity we have to give the ranges. So conductivity which is less than 4 meter per day will give 1, 4 to 12, 2, and 12 to 34 later on. So we have to divide it into these three classes. So I will divide it into these three classes. Give it upper bound values 4, 12, and greater than 12. So there, so 4. So there, you can see it. The range is between minimum is your 24 and maximum is 30. So it's between 24 to 30. So let's see. So it will be all four values, so it's greater than 30. So I think we can take just one class. Just take one class here. Because most of the values are ranging in 12 to 30 values, so we have to assign the four value anyhow. So press OK. So now we have classified all our images according to the table, and now we can rate it according to the table which we are using here. So this is basically taken from the Eller et al. 1987, the approach which was given first for this drastic calculation. Now what we will do is assign rating to each parameter. So we have classified according to the table, and now we will do rating. So for doing that, we'll use reclassify tool. So you can press Control F to find the tool, reclassify. So you can select this reclassify in spatial analyst. Now select D, your first parameter. You need to reclassify, just make sure that you can put some values like 0 to 1.5 will be equal to 10, and 1.5 to 4.5 is 9, and you have 4.5 and greater than 4.5 is 7. So I will name it as dr rating.tif, save it, press OK. So there is some values which are out of range, so let's see, but it has classified correctly, and we have given a rating number. So our 7 is our deep water tables, 9 is moderate, and 10 is our shallow. Now let's do same for our recharge. We'll do same for our recharge values, and use the same tool, which is reclassify. We will select recharge. So there are like different ranges. I think we can correct it here. So let's reclassify here. Like I will make it 3. So just make it a little bit higher so you can capture your. So I will make it a little bit higher so that I can capture all the values. So I have to capture all the values. So 100 to 175 is 6. So I will provide here 6. And then 175 to 250 is 8. So here is a little bit changed. So I will make it 250. I will make it 175. Just make sure that either you reclassified correctly before, so we did some mistake, or you just correct it here. And then there is a value which is greater than 250. So I will take it like 250.1 to 700. We will give it like 6, 8, and 9. So same rating as our. So we will put it as rr.tif, just to check once again that our values are correct. 100 to 175 is 6, 175 to 250 is 8, and 250 to 700 is 9. Press save. So for the safe side, I'm just putting 100 here. So although there is no zero recharge, so just for the safe side. So it's completed. We'll see it again. So you can see it has given 6 value, 8 value, and 9 value as per the classification. Now we will come to over another parameter, which is aquifer. And in our aquifer media, we have only one media, so we just have to put 8 value to all of them. Just assign 8 to all of the stuff. So you can do it here in reclassify tool, or you can simply do it later on. Or you can use Raster Calculator to do this. So for the sake of consistency, I'm using reclassify tool. So I will use input aquifer. My old value is 1, so I will assign new value as 8. So my aquifer media rating value is 8. So I will give it a name, ar.tiff. Press save, press OK. So you will see we will get the 8 value. So that's good. Now coming to S, which is soil media. So our 1 is sand, 2 is loam, and 3 is clay soil. So we'll assign these according to it. So let's do it. Use the reclassify tool again. Use soil media. So 9, 5, and 3. 9, 5, and 3. So check it once again. Save it as sr.tiff. Press save, press OK, and you will get these values. So your 3 is your clay stuff, 9 is your sandy stuff, 5 is your loam soil. So 9 is given to sandy soil because there is high infiltration rate, so the contaminant will be fastly entering the groundwater. Loomy has less, so it's 5, and clay is the minimum, so it's 3. So infiltration is the less in vertical infiltration. So now coming to our topographic slope. So here look like it's not correctly classified. So there are some values which are out of the range. So I will give it 0, and for 0 to 2 I will give. So I just have to reclassify it once again, so I keep it like, because 0 to 2 and greater than 2 we have these two numbers. So we will assign greater than 2 0 values, and in this range we will assign some value as per the table. So let's use again the reclassify tool. Select topography AT, and from 0 to 2 we have to give 10 value, another we can give 0. So because these are outliers, we are not interested in. So we give a str.diff, press save, press OK. Now we have, so there are some values. This is some outliers which we have given 0 value. And there is some value which are really high, 18 values, some maybe more outliers into the system. We can handle it, or we can leave it here, or we can just remove these values, and those which are 18 values, data outliers, exist in our data set. Another way is to give it high range, as we did in recharge, to capture this 18 also, and give it a 10 value. So there are multiple ways to do it. So I will do it again and just give all the number 10 values. So what I will do is basically just reclassify it into one class and just give it a 10 value. So it depends, but because it's all flat zone, there is high risk of contamination in all the zones, so I'm giving it high risk. So it depends on your study area exactly what you want to do. So I am taking it in a high risk zone. So take it as 10. Just give it a 10 value. You just have it a little bit more, so capture all of the values. So we'll assign it as what was that, tr. So tr already exists, we just have to delete. I don't know, we cannot delete it here, so I will give it tr2, save it, press ok. So now you can see we have one value which is in high risk rating. And then we have weather zone. So for silt clay we can assign 1, and sand and gravel we can assign 8. So we have considered like one high risk zone, sand and gravel, so we'll give it 8 value. So it's one value. We will use again reclassify tool. We will use impact of weather zone, and we are keeping it into a high zone, which is 8 value, high risk zone, and we'll give it as IR value. Press .if, press save, press OK. So you can see the whole value will be 8. That's good. And now the conductivity range, again in this we have one conductivity range, only one value will be given to the whole rating. So if we are doing like big regional analysis for a whole Indus basin, these values will vary a lot based on the classification scheme we're using. So we are in like 12 to 30 range, so we'll put 4. I will put 4 here, and I will give it as er.if. Press save, press OK. So now you have created all the rating rasters. Now you simply have to put the DI equation formula. So there is some outlier here also. So this data corrections you have to do so and so forth based on the analysis you're doing, in which area you're doing the analysis. So look, this 24 is outlier. So as this is the one value, so I will just make it sure that I capture this. I will do it again. So just to capture it, so I will assign like, give it some low value also, like 23 to 3, because it's coming in here, and we'll assign it a 4 value. Make it CR2 because CR already exists. So we'll make it CR2. Save it, press OK. You will see this outlier is now removed. Now we have created all the rating rasters. Now we simply have to use Raster Calculator to put this formula where we have already put in included the weights. So we'll do one by one, and you will see it how to do in your Raster Calculator. So open your Raster Calculator. You can search it in your Control F, Raster Calculator. Press enter. So in this section in this tools you will find Raster Calculator. So just see from here. So our first weight is 5. So 5 multiplied by our depth to water table, which is DR rating raster. DR rating raster. Put it into the brackets for calculation. So it's save. Then press plus. Then again the weighting, which is 4. Then RR. There's some problem with the formula. I don't know what's the problem. We'll do it again. Is the syntax error there? I don't know what's the syntax error. Let's see. Again the syntax error, or some kind of syntax error. I don't know what it is. We'll do it again. dr.if multiply by 5 plus. That's okay. I don't know why it was giving me syntax error before. So now we will use again parsing error. It should not come here, but let's see. We'll put all the formula and then see it in. Now recharge, and our vector is 4. Waiting. Oh, sorry. Our waiting is 4. Then after recharge is aquifer, AR. Waiting of aquifer. Then we have to multiply it with the weights. It's 3. Then again we have to multiply S, which is our soil, and SR into 2. SR multiplied by 2 is the weighting of SR, then plus TR into 1, so simply TR2. Then we have IR into 5. IR multiplied by 5. Then we have CR multiplied by, so we just put in the brackets, multiply by 3. So now this is our drastic index equation. We are using rating rasters multiplied by the weights and adding all the parameters. Now we'll give it di.diff, which is your drastic index, or you can give it a vulnerability also. Press OK. So it has calculated your vulnerability index, groundwater vulnerability index. Now you can easily classify it. You classify into the range of this, so you know which is low vulnerable, moderate, and high and very high. So 100 will 100 upper than 140, 200, and greater than 200. So let's see. It's 100. So our lowest is 151. So we are already in high vulnerable zones. You can simply classify it into some less, like 2 values. So because we know that now in our zone we have basically just looking at the numbers, you can see our whole data set lie in high vulnerable zone. So it's like only one zone, 141 to 200. These numbers also depend on the area which you are working in. According to my experience, this number has to be changed in this area a little bit. Like this is because of the weighting and rating. The weighting and rating has to be according to the area. So we can just simply give it one class. It is 151 to 190, which is in the range of high vulnerable zone. So we'll give it. Just give it more like a red color. Press OK. So over this area, because this is only one district, this kind of analysis is more suitable for the basin level analysis. You will get more zones when you will do it for larger area set. So this area is missing because we did not have data assigned here, and this is also not agriculture area. So all desert, nothing is happening here. So this is river bank, so this is nothing happening. This is the area where people are extracting and using the water. So in this Nawabshah region, there is high vulnerability. This is because of several reasons, and one reason is the flat topography and shallow water tables. Thank you very much, and I hope this video was sufficient to understand drastic index. And the only thing which to understand is like you need to work out the rates and weights. All other process is quite straightforward. Thank you very much.